Good morning, everybody, and welcome to ARC's third quarter web window on edge computing and IPCs. My name is Anne. I'm the moderator for today's session. So without any further ado, I would like to pass over the word to today's expert, Fabian Wanke.
Good morning, Anne, and good morning, everybody. Welcome from my side, and thank you for joining our today's webinar, where I'm going to talk a bit about edge computing and IPCs in manufacturing. And today's agenda is about edge computing for sure, and why edge computing is a chance also for IPCs. And due to the fact that I was last week at the EMO fair, one of the biggest machinery tool exhibitions worldwide, I want to give some impression and insights, especially linked to edge computing. As you can see on that slide, computing has gone in massive cycles, shifting from centralized to distributed and back again. And now move to the edge is just another manifestation of that. I don't want to say that cloud computing won't continue. Absolutely not. It will have a key place in the computing ecosystem, but the role, especially due to edge computing, will be changed. Just some ideas, and I think mostly everybody knows that, especially from the cloud infrastructure, you have two possibilities. You have a public cloud or a private cloud. But in fact, I really like that picture of the t-shirt so much. There is no cloud, it's someone else's computer capacity, maybe I want to add. What we see here on that slide, talking about platforms, and especially about different platforms which already exist and more coming up. Here at ARC, we speak about 4 IoT platforms, and I don't want to spend too much time on it. I just can recommend you to read the blogs from my colleagues from the US, and we will soon bring out and study on the different platforms. But when we talk about IoT platforms, we talk about especially the device connectivity platform, the compute platform, the cloud application platform, and analytics platforms. So when we talk about IPCs, it's hardware, and I just want to highlight that compute platform, because even today, the infrastructure as a service, there are really worldwide 3 big players. And this is something really political and also interesting, because maybe there is also place to offer infrastructure as a service, and not just all the application platform or connectivity platforms. And especially in Europe, you should think about that. It's my personal opinion. This is just an illustration of how the connectivity from the edge to the cloud is currently being done. For sure, there are many other possibilities, and it's really just an example. But you already can see here that it's quite complex. Yeah, you have the devices, and you have a gateway. You send it to maybe on a server, then to the switch, and up to the cloud or to the industrial infrastructure, or whatever you have on premise or use public. Coming to the edge, the question is, where is the edge? And I think most of you already know that the edge computing has data applications and services at the logical extremes of a network. I mean, near the sensor, or already in devices generating data, but for sure it's away from centralized cloud data centers. Data management, communication, and also some analytics secure at the source of the data. So again, in each device, which is much smaller in scale compared to the cloud. This small data approach allows each local device to assess its own health and performance, at least, particularly when immediacy of decision making is critical. And with pre-processing at the edge, big data in the cloud can become easier to manage. The edge includes many different smart or intelligent devices, like instruments, controllers like PLCs, CNCs, and more general purpose computers, also like Raspberry Pis. These devices have edge computing functions, including a network connection, storage, and some software specific to the device at least. The edge also includes smart sensors and sensors that connect the network gateways or other devices having the edge computing resources. Talking about the difference of edge and cloud computing, I like an analogy from the automotive industry. If you think about, for example, in electric cars, which already contains a lot of electric and software, for example, to assess the health and performance of its batteries. So the battery management systems reads the data from the sensors, stores it, and do some analytics, for example, to alert the driver when health of the battery decrease. So this is a good example for small data analytics with edge computing. But when it's connected to the internet, data is uploaded to the cloud where more advanced analytics can be assessed. And for example, due to the performance of a range of cars, driver profiles, driving conditions, and so on can be analyzed. And for sure, this goes back, especially for the designs and engineering for better batteries, or just to avoid traffic jams, and so on and so on. As I already mentioned, what happens at the edge? At the edge, we have currently especially some data storage, buffering, communications, filtering, preparation, transportation, and limited analytics when you compare it to what is available and possible in the cloud due to just computing power. Typical applications involve algorithms to assess equipment health and alert the operator when issues arise. In addition, analytics for improved process control have recently started to emerge. And on the cloud, similar applications for health monitoring and process optimization exist, but with the added capability to aggregate data from many IoT devices, the higher volume of data with its inherent added complexity is combined with more advanced analytics to anticipate issues further into the future. Thus means strategic decisions support is best in the cloud, and the more immediate tactical decisions have to be done, it should be done at the edge. So why use the edge in industrial environments? In an industrial IoT system with only centralized resources, which is still existing, a network interruption becomes lost alerts, lost data, and delayed problems identification, for example. But this could also involve loss of predictive maintenance alerts, causing unplanned downtime, missed opportunities for process optimization, and so on. Resources at the edge may help to mitigate these network outage issues. Related constraints with similar impact include network latency and bandwidth problems. So edge computing helps to mitigate a single point of failure for a more robust IoT solution when part of the network is compromised by physical or hardware or virtual software or security failures. So talking about a robust architecture is inherently more resilient to faults and other perturbations. With edge computing, data storage and computation occurs at the edge for more real-time issue identification and to buffer data during network issues. Then sent to the cloud only the data needed for more sophisticated analytics, as, for example, would apply to longer-range predictive maintenance. And this pre-processing at the edge helps reduce network bandwidth and cloud service needs. And I really liked a statement from a machine builder at our last year's European Forum who said, I will never send all data to the cloud. I really want to avoid a data tsunami with data which is not necessary to be analyzed. So usually most edge data are noise to a larger system in the sense that it has no real use. For example, when monitoring condition, do the centralized resources really need the data when nothing changed? This is really a question everybody has to answer on its own. But when changes, anomalies are detected, there is no question, then the data should be transferred. It doesn't no good to use data transport, storage, and processing resources putting data into the cloud when it's not useful. For industrial organizations, this technology will become more and more critical in following cases when we talk about, sorry, I was too fast, low intermediate connectivity, bandwidth problems. I just mentioned it. and many things more. What is also interesting and why I put that slide on is that there is Edge Computing Consortium, an initiative which also identifies many outcomes, but not just for industrial organization, also when we talk about smart cities, smart cars, all the automotive industry, and so on. I can just recommend to have a look at that website of the Edge Computing Consortium. As I mentioned, Edge Computing offers many possibilities and outcomes, not just for industrial organization. The industrial IoT applications often involve mission-critical objectives for asset-intensive industries, like reducing unplanned downtime, improving working safety, and enhancing asset performance. So edge computing assures also a robust architecture, more resilient to issues with the network or centralized resources. So today, many original equipment manufacturers already provide condition monitoring services to their customers. For particular critical machines, end users have developed own condition monitoring applications, so it's a really heterogeneous market. And when the service is not available from the OEM, so people or from other suppliers, companies start to really build their own solutions. So, and both types of users of IoT solutions should consider edge computing to make their solutions simpler, so data pre-processing at the edge, just what I mentioned, and especially more robust, so no single point of failure. As you can see here on that slide, you have a lot of edge infrastructure devices. Everybody's talking about, and you see so many offerings of different gateways, switches, routers, and wireless access points. But what is not highlighted, and I will come on that to the next slide, I don't see, especially from marketing perspective, not many who are offering IPCs for doing that. And before talking about the advantages of IPCs, I want to talk a bit about the industrial IPC market and the dynamics. So the drivers, I think, are already known in most cases. We see a clear demand for more data, especially also in manufacturing. There's demand for more functionality, for more flexibility, and at the same time, even in Germany, also in Asia, all over the world, we see an increasing acceptance of PC technology also in the automation industry, and a demand for increasing computing power. Other trends, what we see, that robotics, everybody knows, is really, the automation is increasing. Robotics plays a more and more important role across all industries. We see IPCs are more and more used for data acquisition. Also act as a gateway, already they are in use, and especially with the rise of more high resolution vision systems in combination with IPCs, this is also a trend where IPCs vendors have really big chances. Other trends is end users are really looking for open, non-proprietary solutions. And another trend is that lines between smart devices, for example, gateways and IPCs, are blurring due to the fact that both get more and more computing power, more connectivity possibilities, and also the prices are decreasing. So this is also a clear trend what we can see over the last years. Why should you offer or use IPCs at the edge? First of all, it can be used as gateways and easily be scaled up and down. So IPCs are offered in all kind of ranges. Customization is absolutely possible. Also, you have a lot of standardized products. IPCs offer a lot of computing power compared to many other small devices. You have the possibility to run several tasks, also maybe to use it as a controller and do analytics on an IPC. But there is a question of redundancy, so there is not one solution. You really have to think about what suits for your issue or problem best. And also we can see the rise of so-called single board PCs coming from the consumer side, that more and more companies are playing around with Raspberry Pis or Arduino-based PCs, which are modified into industrial IPCs. And we still think that will continue. Also, IPCs offer freedom of software choice and cloud connection. the integration into brownfield manufacturer systems is not that difficult. It always depends, and you really have to look at it. Maybe it's easier for you and not necessary to have that high computing power, then you can for sure use other devices. And what is really, really important, and if you connect your things, think about security. Yeah? I think everybody is aware of it, and I don't want to spend now too much time. I just can offer you, if you have problems or concerns about security, contact us, and I will give you more information about that, especially from our expert in the US and also here in Germany, which are cybersecurity professionals. Last but not least, I want to talk about impressions and insights from the EMO, as I mentioned at the beginning. So what we find out when talking to machine builders, but also to end customers, there are already many IPCs additionally installed, not just into the machines, also into lines, and this offers really, as I mentioned, many possibilities. Another trend was that more and more really big fancy panels we can see at the machines, and also really high resolution vision systems. So vision systems is really since years, but still a trend, and cameras are getting more and more sophisticated, better resolution. This is really impressive. Also impressive was that Siemens, what they at the pre-press conference announced, connected more than 240 or around 240 machines at the EMO. Many end user machines, but also due to that, talking to end users and also machine builders, they still struggle to connect different machines with different control systems from different vendors. This is really still an issue, and with that issue, many solutions of connecting devices or machines are already available. So we can see here a real heterogeneous market. That's also why the VDW, so the German Machine Tool Builders Association, presented a new industry initiative for network production. If you want to hear more about that, you can contact me. For sure, we will write an insight about the EMO findings. Other impressions were or insights, and what was really interesting is that the Japanese EU cooperation was highlighted at many booths, and especially at the press conferences, for example, of the Japanese Machine Tool Builders Association. This is the way it should be, yeah, that you have, wherever your production site is, have your connectivity and you decide what you do. But we have to think about and break down frontiers and to bring that forward. OPC UA, everywhere readable solutions offered, so it's also the basis in the machine tool industry, so highly accepted. Also there are other solutions available. We've seen many additive manufacturing builders, so 3D printer builders. It's booming, but it's still in its infancy. And what was really interesting also there is that they use completely different control systems. Yeah, for sure, with more access, they also used in printers CNC controls, and for smaller printers, we also saw solutions which had a Raspberry Pi as a controller for the 3D printer, which was really fascinating. At the CMTBA, so the Chinese Machine Tool Business Association, we had some talks and the possibility to discuss with the president, and he clearly sees that automation degree will increase, and also they announced it. So wages are rising, everybody knows that, and for that automation is also on the rise. Same for the Japanese Machine Tool Building Association. So domestic and foreign markets are recovering, especially demand from China in electronics and consumer goods are driving the Japanese machine tool market. the most important sentence for me at the press conference was that more and more OEMs from all over the world set up plants in China to produce locally. So exports from especially machine tools maybe are going down a bit, but if you see how many OEMs and machine builders set up plants in China, you see that the exports shrink, but the turnover of companies in China is still on the rise. Last but not least, I would like to just recommend you to have a look at our Industrial IoT website, where you find a lot of interesting blogs from my colleagues all over the world, especially about what is happening in automation industries. Have a look at it. It's great. You will find a lot of interesting information about all subjects. So thank you for attention. That's from my side, and hope that you will join the next webinar of ARC.
On behalf of ARC, thank you for joining us, and thank you for your precious time to view our presentation. Thank you, Fabian, once again for your interesting presentation. My name is Anne, and I wish you all a great day. Thank you.